Good evening, students. This semester, we are going to talk about fabric construction under textile technology. We discussed or we learned about fibers in the first semester. Textile fibers, how to process the fibers to get the yarns. Now we've gotten the yarns. How are you going to use the yarns to produce fabrics? It's what we are going to discuss this semester. So we are talking about fabric construction. So what is fabric? Fabric or cloth is a material made by weaving, knitting, knotting, netting, braiding, etc. by using spun cotton wool, silk, or continuous filament yarns like nylon, polyester, etc. The process of making cloth is termed fabric or cloth formation or fabric construction. The process of cloth formation or construction starts from the preparation of the raw material. That is preparing the fibers into yarns, goes through a whole lot of processes. So making it suitable to be spun into yarn, which is then woven, knitted, or bonded into fabrics. Weaving is one of the fabric construction methods and is the most widely used fabric construction method and provide a designer with a wide range of weaves. So let's look at the fabric construction methods. We have weaving, crocheting, knotting, knitting, lacing, plaiting, braiding, netting, and non-woven fabrics or bonded fabrics. If you talk of non-woven or bonded fabrics, we are talking about fabrics which are produced without going through the above. That's the weaving, crocheting, and others. That's interlacing or interlooping of yarns to make them. But rather, we add adhesives or we agitate them by using pins to put them together into a sheet. So examples, we have some blankets, we have diapers, tissue papers, and others. So you want to take the fabric construction methods one after the other. We are going to discuss about three, that is weaving, crocheting, macrame, or knotting. This is what we are going to look at this semester. So what is weaving? It's the interlacing of warp and weft yarns on a loom to form a fabric. It is the interlacing in different repeat patterns of two sets of threads, the warp and then the weft, crossing each other at right angles set up on the loom. So we can say it is also the process of producing cloth or fabric by pressing two sets of yarns. So we have two sets of yarns or threads over and under each other at right angles. So the warp yarns or the ends or chains lie along the length or the selvage of the fabric, whereas the weft yarns or picks or fillings lie across the width of the fabric where we cut. Okay. So the machine used for weaving is called the loom. So this is the loom. So you can see the loom with fabric on it. So a woven fabric on the loom. So this is the traditional loom. The other one is called the broad loom. This is the traditional loom. That's the traditional kente loom. The loom used to produce our traditional kente. So what is the loom? The loom is a device, apparatus, or machine used for weaving. Depending on the weave structure, example, plain, trill, and satin weaves, a designer select an appropriate loom to produce that fabric. So depending upon the type of fabric that you want to produce will determine the type of loom that you want to, that will be used for that particular weave structure that we have selected. So we have two main types of looms. We have the manual looms and then the power looms. You talk of manual looms, they are operated manually by foot or by hand. So man operated. So that's manpower. So these looms include the broad loom, the traditional kente loom. We have table loom. We have frame loom. They are all manual looms. They are operated manually, either by hand or the foot. So the power looms, what are the power looms? These power looms are used in the textile industry to produce fabrics. Unlike the broad loom, which is foot powered and hand operated, these looms are electrically powered and their operations are automatic. So the power looms are operated by electricity in simple terms. And they are subdivided into two. You have the shuttle looms and then the shuttless looms. So what are the shuttle looms? These are looms, these looms need shuttles to operate, and they include tappet loom, dobby loom, jacquard loom. Then we have the broad loom. So this broad loom that we can use our hand to operate, we have ones that are being used at the industry, which are electricity operated. So the next one is the shuttless looms. So the name implies they are shuttless. That means you don't use shuttle when it comes to their operations. So the shuttless loom do not need shuttles to operate. Examples include projectile looms, rapier looms, air jet looms, water jet looms, etc. They don't need shuttle to operate. We have a mechanism that can propel the weft yarn across the shed. So we have motions on the loom. We have various motions on the loom that are put in place when it comes to weaving. So these various motions, we have the primary motion, the secondary motion, and then the auxiliary motions. So for the loom to operate, we need these motions. So what are the primary motions? They are also called basic motion. They are responsible for the interlacing weft and warp yarns on the loom, and they include shedding, picking, and beating up or beat up. So the primary motions are also subdivided into three: shedding, picking, and beat up. Let's look at what is shedding. Shedding is responsible for the separation of the warp yarns into two sets. Remember, I've been talking about the warp sheet, the warp sheet. So they are the warp sheets. Anytime you want to create a shed, depending upon the way we have threaded the yarns, you can step on one of the treadles and then there will be a shed for you, because when you tread on one of the treadles, because of the way we have done the tie up, one set of yarns will go down and another set will stay. Then there will be an opening, and that opening is called the shed. This one will be so easy when we go to the loom. So when you start the practicals, these things will be will be very simple for you to understand. The upper and the lower layers, which are raised and lowered alternatively to form a shape or an opening through which the shuttle passes. So what you see here, you have one layer up, then another layer is down. This is possible because a treadle has been pressed down. So it's taking all the shafts that are having maybe shaft one, shaft two, shaft three in plain weave, shaft three and shaft one. When you press, those yarns on those shafts will go down, then two and four will stay. So creating a shed for you. And this, what you are seeing here is called a shuttle. So you can see the eye carrying the weft yarn. So when the shed is opened, or when the warp yarns are open, creating the shed, then we lay in the weft yarn. And that one is become possible with the help of the shuttle. So later we talk about the shuttle being an accessory. So we have the picking up motion. What is the picking up motion? I have already explained it. That's the laying of the weft yarn inside the open. So the function of this motion is to propel the shuttle containing the weft yarn through the open shed, which has been created by the shedding motion so as to lay a weft yarn across the open shed. That's very simple. So here you can see the shed open. Then the shuttle is being hot. It's ready to be thrown so that to lay the weft yarn. So after you have laid the weft yarn, then there's another motion called the beating up motion. So what is the beating up motion? This motion is responsible for the beating, forcing or packing of the weft laid in the shed close to the preceding weft yarn at the fell of the cloth to make it compact. So as soon as you lay the weft yarn, then this is the reed. Then you use the reed to beat the newly inserted yarn to the very end of the fabric. That's the fell of the fabric. So you can see it here, the fell, the very end, ready to receive the new yarn which has been laid. So you use this one, which is the reed, to beat the newly inserted yarn. So after laying the yarn, you take away the shuttle. Then you use the reed to beat the newly inserted yarn to form parts of the fabric. Okay, so that is it. So the next motion is the secondary motion. The secondary motion also comes with two activities. The first one, the basic, the primary motion comes with three activities. That is shedding, picking, and beat up. The secondary motion comes with two. That is take up motion and then let off motion. What is it? The secondary motions are designed such a way that the work is being woven. Fabric is also being wound up onto the cloth beam simultaneously, thereby ensuring a continuous weaving operation while maintaining constant warp tension. So they include take-up motion and left-off motion. So you can see this here. So in the course of weaving, the whole place here will be full up. So when it comes like that, you need fresh yarns for you to weave. So you need to wind this onto the cloth beam. So winding this onto the cloth beam, as you wind it, new fresh yarns will automatically come. So the new yarns coming is called let off, and the old one already woven yarns taken to the cloth beam is called pick up. So they happen simultaneously. As you wind this one automatically come because we're pushing this and this one to hot. And we have a mechanism because whilst it is like in this state, it is fixed. So we have the ratchet power. When that wheel is released, so you can wind the fabric. And when it comes to the length that you want, then you lock it again. Then the tension, you maintain the tension throughout the weaving. And when the place is full, then you wind by releasing the ratchet power, then the ratchet or the wheel. So what is the let off? This motion gradually releases the warp beam to be woven into fabric. Okay. So the auxiliary motion. The auxiliary motion, that is the third motion. the third of the various motions. That one happened at the industry where they use the power looms. The power looms, because it's being operated by electricity and it's automatic, when there is a problem because of the weaving, the machine will automatically hot stops. And when it stops, there will be an indicator indicating to you that there's something wrong. Then you check the indicator. The indicator will tell you what is wrong. Then you go and fix it and start the machine. So these are helping motions and devices that are functional on the power looms for effective weaving to take place. Examples include warp stop motion, wet stop, shuttle box empty, shuttle stop. So when there is a warp stop, also this stops the loom automatically if a warp yarn breaks. So you go, then you what? You amend it, then you set the machine to operate. Wet stop. This stops the loom automatically if a weft yarn breaks or a bobbin is exhausted. So you go, then you fix, then you continue the process. The same thing applies to the rest. Okay. So now we are looking at the loom parts and loom accessories. The loom, the structure. Part is what forms the loom and what are the accessories. The accessories are the devices that speed up the weaving activities. And then the loom parts are the main parts that make up the loom. So these are part, the loom parts are part that make up the loom. Example, you have the cloth roller, treadles, pulleys, pedal, shafts, lamps, and etc. Then what are the loom accessory? It is an essential device that is not necessarily a component part of the loom or of the loom structure, but used as supplement in the weaving operation. In other words, they speed up weaving activities. So we have examples here. So let's see. We have the loom parts and loom accessories. So this is the loom. So these parts here you see, the upright spool, the handles, the head roller, they are all loom parts. Then the shuttle is an accessory. It doesn't form part of the loom, but without the shuttle, you cannot do any proper weaving. The treadles, we have the crossbar, they are all parts of the loom, the breast beam where you sit. So here is at the level of your breast. That one too is hot. It's the loom part. Okay, let's see the loom accessory. So here we have the reed hook. The reed hook is used to hook the yarns through the reed dents. So we have the warping mill. This warping mill is the one you start with after planning and designing. You have the number of yarns that you are going to use. It is this structure that will help you to organize your pallets, organize your yarns to the very ends that you will need. So you have the shuttle helping you to lay the weft yarn. You have the rattle warping you need to spread out on the loom. All these things will become very simple for you when you're doing the actual weaving or when you go to the weaving room where you see a lot of uh, uh, looms. And when we start at the actual practical, these things will become so practical for you to see. We have the pedal hook, then the pen winder, where you use this one to wind the weft yarn, which we can put inside this shuttle. These ones are pens or empty bobbins, like bobbins that we use in the industry. So now the basic weaves. Now that we know the looms, what are some of the weaves that we can weave on the loom? So we have three basic weaves. We have basically three basic weaves. We have the plain weave, the tulle weave, and then the satin or satin weaves. But the variations are almost endless. With the plain weave, we have a whole lot of variations. The twill, we have a lot of variations of the tulle weave. The satin, we have a lot of variations of the tulle weave. So they are endless. So the way the work and then the warp and filling threads, that is the weft, interlace with each other on the loom is called the weave. Majority of the woven products are created with one of the three basic weaves. That is, they are mentioned up there. So let's take the plain weave. What is the plain weave and how is the structure like? Okay, so this is the simplest of all the weaves, where the threads running in one direction pass under and over alternate threads running at right angles to the right set or to other side of the fabric. Yes. So we have the basic weave. This one is the plain weave. We have the trail weave. Then we have the satin weave. So you start from one end, then it go to one side, then you come to the other side, then you go to the other side, up, down, up, down, up, down, up, down, up, down, up, down. So this one is one up, one down, one up, one down, one up, one down, as you can see here. The true weave is identified by its diagonal lines on the surface of the fabric. And we have its own structure. Then we have the satin. It also floats. You see a whole lot of floats on the surface, and that comes with its own structure. Okay, so you can see it better here. So this is the plain weave, 1/1, 1/1, 1/1, and this is the trail weave. You can see the diagonal lines across. We have a special way of constructing it. When it comes to the construction, you will love it. Then you have the satin. The satin, you can see floats, the number of floats. And this one is one variation of the trail weave, where you see it going up and down, up and down, up and down, up and down. That is the herringbone weave. So this is the plain weave. This is how we construct the plain weave. So we have the work yarns, that this the points or the dots, the big dots here are representing the work yarns. So you use the weft yarns to interlace, interlace up and down. So that's what you can see here. That's what you can see here. So you start from here, up, down, up, down, up, down, then you go back, then you come, just like you're weaving a basket. Okay. So what are the weft yarns and what are the warp yarns? So the vertical ones. So you can say vertical warp and horizontal weft, sorry, horizontal weft and vertical warp. So the ones going back or vertically are called the warp yarns, as you will say, warp yarns. And then the one for the interlacing on the horizontal side are called weft yarns. So that is the plain weave. One up, one down, plain weave. So the variations, it's 1/1. So as soon as you increase the one, it becomes a variation. If it is now 2/2, it's a variation. If it is 3/1, it's the variation. Okay, but they all have names. So let's see. A variation, a variation of the plain weave would be a hop sack pattern, where the yarn pass over two and under two crosswise yarn alternatively. It is also called basket weave. So example is the monk's cloth. When you use it to produce a fabric, you have a monk's cloth. So this is 2/2, 2/2, 2/2. So you can see it here. Okay. So the warp rib structure has more warp yarn shown per unit space than weft. So we have another variation is the warp rib weave. then the weft rib weave. So here you see we doubled the the yarns. So 2/2. Initially, it was 1/1. So when you decide to make it 2/2 or 3/3, it becomes another wave, but it's still the plain wave variation. So here is 1, 2, 3 on the warp side. So that one is called warp rib. Then here, 1, 2, 3, a float before, under, and over. That one is on the weft side. So it is called a weft rib weave. Okay, so you can see better here. So 2/2, 2/2, 2/2, 2/2. So that's the basket weave or the Mons claw. So that's what you can see here. Okay, so let's look at the characteristics of the plain weave. It is less elastic because it's 1/1. It's very strong, has a very strong structure. It is the simplest and most firm weave structure. It is very smooth and very stable and very strong weave. Okay, you will end here and continue another time with the trail weave. Thank you.